Hi everyone, my name is Abel Grey Cantoma. I'm from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number. You can call me on any of these numbers, okay? Today I'm going to be showing you something very interesting I recently just discovered in our Protastructure 2022. We'll call this the engineering utilities, okay? Alright, you can see here we have cover and anchorage hook length. So you can use this to manually just check, most especially when you are probably doing your design manually, or you want to analyze manually rather. You can actually use all of this to make your work much more easier and even faster. Okay, so in terms of your cover and anchorage, it helps you most especially when you are doing your detailing manually. You can easily just get to know what anchorage length or what lap length that you should use in your detailing. Okay, same thing implies when it comes to your hook length, when it comes to reinforcement bar area. You can easily know the area of your reinforcement. Okay, then unit conversion, how to convert different units. I'm going to go deeper into all of these. I just want to give you a quick brief of what engineering utilities is in our Protastructure 2022. So you can convert from centimeter to meter, from millimeter to centimeter, from millimeter to meters, from millimeter to whatever unit of measurement you want to use. You can see we have decimeter, inches, feet. Okay, so it helps you to do all that very much easier and even faster. Simple beam analysis. You can do quickly analyze and know your final result. I'm going to be confirming that with the manual calculation I did, and you are going to see that it's actually agreeing with what we have here. Okay, so you can do that for a cantilever beam. You can do that for fixed at both ends. That's, you have a fixed support at both ends, and then you have fixed at one end and the other end is actually not fixed. Okay, you are going to see all of that as we progress. And another interesting part of this is that you can achieve, you can use this to solve to know your discharge. You can also to know your flow depth. You can also use to solve for channel width. You can also solve for your channel slope. All of that, we are going to be going deeper into all of that, and I will show you. This is for uniform flow depth. Okay, so once you know the depth, and then you know the bottom channel width, as the width of your channel. Okay, so your Manning's roughness coefficient, you type in that, and then your channel bed slope. You can easily just punch in those informations here, and it will quickly tell you your discharge. Okay, so it will solve that for you. It spares you the stress of punching, doing a lot of manual punching and all of that. Okay, so let's jump right into it. All you need to do, once you have your Prota detail here, you need to just come here. You will see in our Prota detail 2022, I've not confirmed in 2021 yet, but in 2022 you just click on this drop down here. You will see where it is written engineering utilities. Click on your engineering utilities. You come to cover. We are going to be starting here. Come to cover and anchorage. You can see, so whatever structural element you want to know, the cover or the anchorage, all you need to do is to pick on that particular element. So if I'm picking for beam now, for example, all I need to do is to come to my reinforcement bar material. If I click for my reinforcement bar diameter, if I click here, I'll come under where I have my beam. This is my beam. I have to select the beam that was used in my analysis and my design, probably while I was doing my design. So if 16 and 20, for example, where the reinforcement I used, I'll click on OK. If I click on OK, now you can see the beam was what I picked here. And then the rebar position, I can also change that to either top or bottom. So and then the concrete design code, I can pick whatever based on the concrete design code I must have used. Then my reinforcement bar, so for Y16, this is exactly what we are going to be getting as our lap length and also our anchorage length. So if I switch this to Y20, automatically you can see the lap length and your anchorage length has actually changed. I can as well also select my or type in my concrete cover here. So similarly, for every other structural member that I may want to achieve, I can do that similarly for my column as well. I can also do that for my slab. Now when I switch to slab, you will discover that there is been a change. Okay, so you can see the lap length is changing even for that of our column. Remember, for our beam was 998, which is approximately 1 meter. When it comes to our column, you can see it's changing to approximately 900. When it comes to my slab, it's changing. So this can automatically tell you the lap length that should be used, probably when you are doing your detailing or you are on site and you want to know the right lap length that you should use while you are on site. Okay, your hook length is similarly with that of our cover and anchorage. All you need to do is to select whatever, make sure you set every structural member. Like for the column, you can see here is 16 and 20. I'm not designing any wall, so my beam, you can see, is 16 and 20. My slab, I only selected Y12. My foundation, I selected just Y12, and my links, I selected Y10. Okay, so if that is correct, now this tells me for my link. Okay, you can see is here we have Y12, which is exactly what I picked in my selection there. Now it depends on what particular angle you are taking your hook to. If it is at 90 degrees, you can see it's giving us all the necessary information. You can see the bending length, the extension length, the total hook length. Every information that has to do with that is coming up. And like I said, if you switch to any code of practice, you can see it changes. But like you know, your British and then your Euro code are more like just Euro code is just an improvement of your British code, which most of us are very much familiar with. Okay, so you discover that there has not been any change here. So reinforcement bar area calculator, this tells you your area per meter. Okay, so you need to specify the span length. What is the particular span? For example, if you are dealing with a slab, you know the particular span of that particular slab. Okay, what is the maximum spacing that was provided in your detailing, the minimum spacing as well. That will help you to be able to determine the area per meter. Okay, so you can take your time to play around this. As you are changing those informations, you will discover the area per meter is actually changing as you are changing those informations. Okay, so if you come to unit conversion, you can see this is telling you for length. So if you want to know the conversion in length, so if you are converting from millimeter to centimeter, this will tell you based on what you have. So if you are converting a 100 mm to a centimeter, automatically this is what is telling you. This means this is 10 raised to the power of 1. So it is 1.000 plus 001. So this means 10 raised to the power of 1. If I change this to 1000, you see this is telling you this is 10 raised to the power of 2, which is going to give you 100. If you punch that in your calculator, okay, so similarly for any value, it will tell you, it will automatically convert that for you. So if you are taking this to, you can see this is plus 00. Let's say I'm taking this to meters. You know that 100 millimeter make 1 meter. Now if that is correct, this is telling us that if we are converting a millimeter to a meter, is telling us that 1000 millimeter makes 1 meter. So that is why you can see here is telling us it is 1 point. This is exponential plus 0.00000. Okay, so what that means is that this is 1 raised to the power of 0, and anything raised to the power of 0 is actually 1. Okay, so anything raised to the power of 0 is 1. I just try to confirm that in our calculator too. Okay, so similarly you can get this for 10,000 millimeter, for example. If you punch that and click on enter, this is telling us that this is actually going to give us in 10 meters, okay, which is telling us that this is actually 10, okay, because this is telling us that plus 001. Okay, so this is 10 raised to the power of 1. Okay, please do not get confused. Let me change this to 20 meters in order for you to understand the conversion is actually very correct. So this is going to give us 20 raised to the power of this particular one that we have here. Okay, so that is how it does its conversion. You can see the default conversion rate here is written here, although it's somehow a bit tricky, but if you calm down to understand it very well, you will discover that it's very, very correct. So it converts it for you in terms of inches, in terms of feet, in terms of millimeters, in meters. So you can do that conversion from centimeter, from inches to meters, and all of that. So you know that your inches is equivalent to 150 approximately 150 millimeter. Okay, so let's say you know that 6 inches rather is approximately 150. So you can see this is what we have. This is 1.524, which is approximately 1.5. okay, so if that is correct, so this is telling us that this is actually converted in terms of our millimeter, which is approximately 150. Okay, so if that is correct, let's jump right into the next one, which is simple beam analysis. For this, you can do a simply supported beam with hinge support, with a fixed support, whether you are designing for analyzing for a cantilever. Okay, you can actually analyze that quickly from here, whether the load that is on it is uniformly distributed load, whether it is concentrated at a particular point, or load increasing uniformly to center. So in whichever way it comes, you can quickly analyze that, okay, here, and it tells you the answer immediately, give you the final value. So you can also switch this to a concentrated load. You can see it's telling us that of a concentrated load. So I was able to manually solve this, and we're able to get this even from our manual calculation. So let's say that the span from here now to here is 5,600, okay, which is 5.6 meters, and then the load that is coming on top of this is actually 30 kilonewton per meter, which is exactly what I have here. Sorry, my writing is actually not too good but you can see what we have here. So if you have your RA here, you have your RB, and then you have this uniformly distributed load at 30 kilonewton per meter, and then the span from here to here is 5.6 meters. So if you say your RA plus RB equals to 0, that is your RA, that's summation of all your vertical forces, okay. So if you are summing all the vertical forces, this is first principle. I believe those of you that are civil engineers going through this must have gone through all of this several times, countless times in your calculations, okay. So you see, you'll be able to get this as your RA plus RB minus, because this is actually a downward force, so it's acting downward, so it's negative. Your upward forces are positive, okay. When we try to apply equilibrium of forces, okay. So this is actually going to give us 30 multiplied by 5.6, because we are converting kilonewton per meter to kilonewton. So when you multiply this by the entire length that this particular load is acting on, okay, because this is uniformly distributed, it is uniformly loaded on top of this particular span. So for that reason, when you multiply by the entire span length, it's going to take off this meter, is going to be in kilonewton. So this will be our RA plus RB, sorry, at taking vertical forces at point A. So this is actually going to go. So we are going to be having our RB to be, sorry, we have RA plus RB equals to 0, because we are starting from here, yeah. So this should automatically be RA plus RB. Sorry, that's a very big mistake I made. So when you have RA plus RB equals to 0, RA plus RB minus 30 times 5.6 should give you equals to, okay, 0, okay, that's correct. So whatever you have here, RA plus RB minus 30 times 5.6 is supposed to give us equals to 0. So our RA plus RB should be equals to 168 kilonewton, okay, it's very, very correct, okay. Like this. So summation of moment, when you take moment is force times perpendicular distance, which is actually in kilonewton meter. So it's actually in kilonewton meter. So if that is correct, so you are going to be having minus 30 times 5.6 times 2.8. What this means is that we are converting this particular uniformly distributed load to a pointed load. So when you do that maths, when you multiply all of this, taking half of 5.6, which is 2.8, plus 5.6 RB, because this is a moment and we are taking our moment from point A. So at this point, which is our starting point, which is the origin, is actually 0. So if that is correct, our RB is not included here, our RA is not included here, so we have plus 5.6 RB equals to 0. So this will be minus 470.4 plus 5.6 RB equals to 0. So if you make RB the subject of formula and you do all this simple mathematics, 5.6 divided by all of this, your RB will be equals to 84. So by the time you take this from your equation 1, which is this, our RA plus RB equals to 0, if you bring back that equation, which brings us back to this point of saying RB, RA plus RB is equals to 165, which is in kilonewton. So when we have RA plus RB equals to 168, so when you make RA now the subject of formula, this comes back to this side, and when you subtract, this is telling us that our RA is the same thing as our RB, and which is equals to 84. So from our equation, which is this equation, let's say this is equation 2, sorry. So from equation 2, so if we substitute the value of RA plus RB from equation 1, what am I doing? So if we substitute the value of RA plus RB from equation 1 equals to 0, so our RA we know that is 84, our RB we also know that is 84, so RA plus RB is equals to 168. So this is indirectly telling us that from our equation 2, RA plus RB, when you sum them, it brings us back to this point. So we are just confirming that our RA plus RB is equals to 168 at this point. So if that is correct, you know that for our uniformly distributed load, our maximum bending moment is WL square all over 8, which is, and then we know our W, which is the load that is acting here, which is 30 times 5.6, which is the length, okay, raised to the power of 2. This is the formula, now divided by 8. When you do that math, now you are going to be having the value of, so let's do that, multiply by open bracket 30 5.6 raised to the power of 2 divided by 8. So we are going to be having 117.6, okay, which is 117.6. okay. So if that is correct, we'll come back now to our Prota detail. You are going to confirm that what we are having there, you remember we said our RE is equals to 84, our RB is also 84. If you remember from our calculation here, we said our RA is equals to 84 and our RB is also equals to 84. So if that is correct, if you come back here, this is exactly what you're going to have. So our RB is equals to 84, and then our maximum moment is equals to 117.6 kilonewton meter, and then our maximum deflection is equals to 6.15. So if you check for your deflection, you are definitely also going to get this particular value. So you can do that on your own. Just take your time. So whatever length of beam we want to calculate for, if I change this to 4 meters for example and I press enter, you are going to see all the entire values will change. So if you follow this same process of calculation we just did here manually, you are actually going to get this same value here. Is not going to change, but you know we use 5600, okay, so it's still going to bring us 50. What did I use? I forgot what I used here. 56, 5.6 meter. Okay, nice. You can see the value here is giving us a different result because this is not loaded uniformly on the entire span, so it has to be loaded when it is loaded uniformly on the entire span, it gives you back that same result we got. Okay, so if you are loading it at from this span to this span now to 4 meters, for example, the value is also going to change. And if you try to solve this manually, you are actually going to get this same result which was gotten here. So whichever way you want to actually load this particular member, if you solve this manually, this is exactly what you are going to get, with no difference at all. So if you come down now to where we have our hydraulics, under our hydraulics we said we have uniform flow depth, and then we have the gradually varied flow. Okay, so our uniform flow depth, this is telling you the depth of the channel, the width of the particular bottom channel width. Okay, and then it depends on whatever kind of channel you are designing for, whether it's circular, whether it's a trapezoidal, whether it's actually a rectangular. All you need to do is to type in those information here. It depends on whatever you are trying to solve for. So in your calculation, if you want to determine for discharge, okay, you want to get the value for discharge, you already know the depth of the flow, and then you already know the bottom channel width. So if you know the width of that bottom channel, all you need to do is type in those informations here, and then you just make sure that it's under your discharge here. Automatically it will adjust and give you your discharge here, which is our results that we are actually looking for. So let's say I change this value to 1.2 meter and I click on enter. You can see everything that has to do with this has been changed. Our discharge is actually volume all over our time. Okay, so so you can solve for your flow depth as well, in a case where you just want to get the depth. Okay, so if you already know the discharge that you are solving for, if you know the particular discharge, it will give you the exact depth. Okay, let's come back here now and say, you know that our discharge here based on the depth of our flow here is 1.2 meters. Okay, and we know the bottom channel width as 5 meters. Let's try to confirm this now. If we come now to this place that we are calculating for the flow, which is our discharge. Okay, sorry, let's come back here. I know my discharge, which is Q, is actually 14.58. so let's say our 14.58 was the discharge that was given, that we already know, but we want to know, for example, the depth of that particular flow. We already know the discharge, for example, and we just want to know only the depth. Okay, so all you need to do, and let's say our discharge is 14.58. okay, automatically you can see it has bring us back to the depth, which is 1.2, which we got from the beginning. So similarly, for every other calculation you want to achieve, if you want to know for the width of that particular channel, if you just type in the discharge, if you know your discharge and you know the flow depth already, which is 1.2, automatically you can see it's bring you back to that 5 meter width which we got from the beginning, which was this. From the beginning you can see it's 5 meters. Okay, so if you also want to know the slope, for you to get your slope, you must know, at least just have one unknown. Okay, so everything boils down to knowing your discharge, your flow depth, and also your bottom channel width. Okay, your bottom channel width, and also your slope. So if you know, if you are looking for one unknown, whatever that you are looking for among all of these, your discharge, your flow depth, your bottom channel width, and your slope, so whichever one you want to look for, you can actually get that by just simply switching to any of these and it will give you. But you must make sure that you have 3 of these that you know already. That means you must have just be looking for one unknown. Okay, so if you are looking for just one unknown, you can come here and do all of that calculation here. Very simple and easy. Just impute those particular values automatically it brings all of this to you. Okay, so in most cases what we always look for is always probably the discharge and probably the slope, most cases. So if you already have an assumed depth or an assumed width of channel that you want to use, in most cases you know the depth and you know the width, so you just want to know the discharge, okay, that this particular channel cross section can carry, okay. You want to know the discharge that it can carry, or you know the discharge already, but you want to just know the cross section that can actually carry that particular discharge of water and at what particular slope. It depends on whatever kind of fluid that you are channeling. Okay, so that is that for uniform flow depth. Also for gradually varied flow, okay, you can actually pick the type of section, whether it's trapezoidal, whether it's circular, okay. So if you know all that, you know your slope, you know the bottom, you know the depth, okay. So it will just calculate. Once you click on calculate, varied flow is occurred, water surface profile cannot so but then you can as well let me take this. Oh, this thing is, sorry, I want to make this a bit smaller. Okay, it's not coming up though. So but this I can change this, let's say to 3 meters or change to 4 meters. Okay, you can, depending on whatever value you are actually making use of. Okay, so if you know all of this, so whatever information that you already know, if you know all of this, you impute, you know the discharge as well, you can calculate automatically. As you are clicking on calculate, you can see the uniform flow depth is telling you the known flow depth, it's telling you is 0. The critical flow depth is actually 1.36. So you can try all of that depending on whatever cross section you want to also achieve, whether it's circular or trapezoidal or it's rectangular. Automatically this actually generates this for you. Okay, why this thing is not sorry, trying to make this a bit okay, come, let me maximize this. Come here. Okay, all right, that is that so far about your, I just want to show you how you can quickly generate a report for this, but it's not coming out the way I want it to really show. So let me come back here. You can see your anchorage. You can print also the reports for your anchorage. You can quickly print that. Okay, if you love what you are seeing, make sure you just like this video, give it a thumbs up, subscribe to this channel. It's actually free. Click on the bell icon so as for you to always get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of you. Make sure you stay safe and make sure you stay blessed.